As far as the debate one is concerned, certainly when they are to be in, you ought to join. There is no point not joining because that is the best which you can provide.
Mhm.
So have some mercy on yourself. You can provide to yourself the best part, and you won't be getting that anywhere. It's not possible for anyone to barge in or to sneak in Doom School or DOSCOS. It's impossible. And they are all eminent personality, very at a very high position in their respective walk of life. So we need to see and we need to learn from experience. We need to know what can be the case, how can we join them, right? Yeah, Vasudev.
Yes, sir.
Again, the same issue. You join her, Vasudev. Join her, please. Can you join
So,
her? Can you join Vibha?
so she is in the call. At least that's what Skype says.
Just a minute. Add people. Vibha, add. Okay. Fine. So that goes without saying that you will be, but that is not to happen now. That'll happen on 31st when they are all at their respective places. The DOSCOs are to join. DOSCOs, the ones who are there with my child and the other farmers, we call them farmers, C farmer, D farmer, S farmer, SC farmers. So they will be representation of all the farmers along with you're also to look into how can you be a part of the debate when they do join someone from the alumni, from the alumnus list. Alumni, it can be alumni, it can be alumna. It can be either one person joining or it can be multiple person joining at the same time. So that certainly will be the case. We'll be looking into it. For now, let's get to the portion that you did ask. I presume you did ask about current electricity, right?
So no current electricity in specific. At that time, I'd asked for that because of my upcoming AP exams, but now I do not have such a preference in specific.
Okay. So current electricity, if we are through, then we can take few questions on current electricity in that case. I won't take theory. Theory, I presume, is known to both of you.
Yes, sir.
And
I'm
theory
through to
will
the AP level theory.
we can take few questions directly and see that how potent or how good we are on preparedness.
Sure, sir.
The preparedness test, we can take a preparedness test today, right? On the topic current electricity. Vibha, please start recording on the topic current electricity. Right? Current electricity, we are testing waters today. Clear? Shall we?
Yes, sir.
There are, write down. Vibha, I started recording, yeah. Vasudev, Vibha
Yes,
also please record.
I'm unable to find the
Okay.
recording.
So I'm recording. That's probably the reason she can't find it.
Okay, so see to it, Vasudev, that you're able to record it properly. Because last time there was some glitch, I suppose.
So it doesn't actually give you a lot of control over the recording. I mean, it pretty much does most of it itself. So I mean,
So last time there was some glitch, you did record, but you couldn't present it.
no, sir. The recording is available.
Okay, fine. Fine. Okay. So let us write down. There are a host of cells. There are a host of cells, each of 2 volt, each of 2 volt, and internal resistance 0.5 ohm. Each of 2 volt and internal resistance 0.5 ohm. A current of 8 ampere is desired. A current of 8 ampere is desired through a resistance of 8 ohm. No, 5 ohm make it. Through a resistance of 5 ohm. a current of 8 ampere is desired through a resistance of 5 ohm. Mind you, 0.5 is internal. Are you getting it? My rates of cell with EMF 2 volt and internal resistance 0.5. We desire a current of 8 ampere through an external resistance of 5 ohm. Clear? Find which combination, series, parallel or mixed, can get you the desired. Find which combination, series, parallel or mixed, can get you the desired. Which one will get you the desired? Series, parallel or mixed. Which one will get you the desired is first to be gotten. So this first part of the question, let me know which will get me the desired. What I want, I presume I have made my point clear on that front. What I want is 8 ampere current flowing across 5 ohm resistor with the uses of as many as you deem fit cells, each of 2 volt and internal resistance 0.5 capacity. Yes, please. Which combination can get me?
So each cell has 0.5 ohm internal resistance.
Correct. Each is of 2 volt with 0.5 ohm resistance. In the meanwhile, what you do, I was just taking class with the other guy. This is centricity and energy relation, very important relation in gravitation, note it down. Centricity energy relation. This relation tells you what will be path of a particle. Will it be elliptical, circular, parabolic, hyperbolic? Whatever eccentricity you get, accordingly you decide. So this is eccentricity, energy, h. What is h equal to? You can get from here. Angular momentum is h by gm. H square by gm. G known to you, m known to you. Angular momentum h square by gm. That is what is h over here to stand for. G known to you is capital M. Small m known to you, small m satellite, capital M planet. E the energy. If we are known to energy, we get eccentricity through this equation. It can be derived. We do derive in class. I'm sure it must not have been derived in your class. Therefore, for the face value, first you write it down.
They've actually not even taught us gravity.
Yeah. Must not have been. I can vouch for it, undersign it, derived actually in the class. You may not be known to it. You may be completely enormous to it. So write it down, and if permits time, we'll be deriving it as well.
So what is H?
H is this over here. Momentum L by R is equal to 1 plus E cos theta. Are you aware of this equation?
So no.
Have you heard conic? Did you go through conic section? I think you have not gone through conic section, right?
So no, it was last year. It's been a while. I'm kind of.
L by R is equal to 1 plus E cos theta. Were you taught?
So no, this specific form was not taught.
Not taught. Dielectrics, eccentricity, nothing about it.
So eccentricity, I know what this eccentricity is, but I mean, not this way.
Fine. So take L as angular momentum, R as the radius, 1 plus E cos theta. Okay, nevertheless, let's get back to the question at hand. What did we do? Do we know equation for current vis-a-vis parallel and series combination? Are you aware of it? Are you aware of it, Vasudev? How do we get current or how do we get parallel series combination reduced to one cell?
So cells behave pretty much similar to resistors in parallel serial combination. Yes.
Okay.
So,
So what do we get equation for current when it comes to there being n cells connected in series and you want to replace that n cells, those cascade of n cells are to be replaced by one cell, then what should I take the cell capacity and what should be the value of R on capacity as well? What would you say?
although the internal resistance gets added and so does that potentials.
Okay. So what do we say for one cell, the EMF, and what will be the internal resistance? Let's say they are added in series.
So I already
What will
tried
you
for
replace the
adding them
cascade
in.
by?
I tried adding them in series, and you get an equation for which there don't seem to be a lot of any integer. I mean, positive solutions. You get n is equal to 20 plus 2n. So I don't think series is the way to go.
Okay. Now I was referring to the formula firstly. What formula you do get from where you want to extrapolate? There will be a formula from where you'll be extrapolating what can you remove the cascade by, correct? I'm referring to that formula plus quick succession. Then we'll go to the question. The formula, how do we get it? I is equal to what do we get? I is equal to NE divided by R plus NR, right? This is what we get, correct? That means we can remove the cascade by a cell of capacity NE and internal resistance NR, correct?
Yes, sir.
How do we get that? It's pretty simple. You take n number of cells and then you use KVL. These are the n cells that I have taken. This is capital R. They are all of E and internal resistance R, E internal resistance R. There are n cells taken. You write KVL equation, you'll get this result. Okay? Where
Yes,
what is I? I is current flowing through cell. Do we write KVL? Shall we write KVL? When you take a cell, you're aware of, you can take it this way, right? Small r, E, and you can find A, you can find B, you can find the difference VAB. VAB is nothing but VA minus VB, and VA minus VB can be expressed as VA minus VC plus VC minus VB, right?
Yes, sir.
And VA minus VC will be what to us? E to us. And VC minus VB depends on which direction current is flowing. If the current is flowing in this direction, then it will be minus of IR, correct? Why minus of IR? Because current flows from higher potential to lower potential, right? Yeah.
Yes, sir.
So terminal potential difference VAB will be equal to E minus IR. In this case, current is discharging. Sorry, cell is discharging. And if you take it this way, the cell is charged. Then you will get E plus IR, right? Yeah.
Yes, sir.
The terminal potential difference means the operators of the voltage in operation, and that will be either less than EMF or greater than EMF. What is EMF then? EMF is the open circuit terminal potential difference, right? When current is not flowing through the cell.
Yes, sir.
By the way, this is also an important point to analyze over here, and I'm bringing for that it is battery which does work in taking charge from its negative or low potential to higher potential. Remember, out of the battery, charge is moving from higher potential to lower potential, correct?
Yes, sir.
So it is losing energy. But inside of the battery, charge moves from low potential to high potential. And this doesn't happen on its own. It is not an organic process. Why will the charge move? Charge is actually being forced not to move. Think about it. If I'm expanding it. If I place an electron, a positron over here, counterpart of electron, then this will be pushed. This will be pushed. Why will it be pushed? Owing to battery force. Please don't confuse battery force as the force which is because of the battery on the charge. Battery force is the force owing to segregation of charges. The moment you dip the electrodes, charges do get segregated, and this side you have got a collection of positive, this side you have got a collection of negative. Now, when we are taking a positron out, a positron should be back to the cell. So it will be back to the cell, but inside of the cell, what is happening? A positron will be pushed. So what does the battery do? Battery force is pushing it. Are you getting it? Battery force is not aiding the movement. Battery force is pushing it, correct? But the charge is to reach from where it started its journey. So charge will overcome battery force at the expense of chemical energy. That's the reason battery loses chemical energy to take charge from where to where? to take charge from lower potential to high potential against its force, which we call battery force. Are you getting it?
Yes, sir.
Battery force doesn't take. What it take? What it take for that energy? Chemical energy. The battery loses energy every time it is to make the charge move from low potential to higher potential, and that is where from the charge gains energy. Battery is doing work on it, correct?
Yes, sir.
Again, it is to lose incorrigible, getting back to battery, seeking for energy. So this process continues. Battery is no bank of energy. Please don't ever be confused that we are drawing charge from battery. We never draw charge from battery. Whatever you are drawing to facilitate your adjustment, your distribution. The same amount of charge should return to battery. Okay, dear? Only then the circuit is to us ambivalent. S is not. Clear?
Yes, sir. Yes, sir.
But viability of the circuit will depend on whatever you have drawn should get back to it, because we can never draw charge from a cell. It's just a methodology by which we are able to distribute charge, and it is just a methodology by which we will be in a position to say that yes, battery is a force. It is not a bank. It is a force to establish flow. It is not a bank from where we can extrapolate or draw charges. Fine, dear?
Yes, sir.
Okay. So this being done, there are n cells. You know what will be VAB. If I mark this A, if I mark this B, then n cells will get me N E minus IR firstly, and then current is flowing, let's say this way, right? I've
Yes.
taken this way, VA minus VB. If I do, then I get, I'm going this way, VA minus VB, what I get? N times of this, correct?
Yes, sir.
Because there are n cells. So current is flowing this way, I'm moving in a clockwise sense. So minus of I into R is equal to what to us? 0 to us, correct?
Yes, sir.
This will get us this equation, and this equation is now to be decoded, deciphered. By this equation, what I mean? By this equation, I mean I have not changed capital R, I have not changed small r. Then what this cascade should be removed by one cell of what capacity? NE, and internal resistance NR. Got it, yeah?
Yes, sir.
Equivalent means outside should not get any inkling on the changes that you have brought inside. Okay? Outside is alien to the changes you are bringing inside.
Yes, sir.
Okay. So this is what we get. Now to us, I want this to be changed to 8. I want this to be changed to 0.5, this to be 5, and this to 2. Seek value of n. What do we get n from here? If we do get n, which is cogent, we'll go ahead with it.
So
If we
you
do
get the
get n,
negative
which cannot be realized, then we have to say that we are not going to get this through series combination in any way established. Yes, please.
So you get a negative value for n.
Negative value. It says, what are you then trying to decode of it? Tell me.
So it's not physically possible to get those parameters.
It is not possible. It's not possible. It doesn't speak. It's not in. I will say it's incongruous. It's not in connivability. So what we say, series combination is incongruous. It is not together. It's out of place. Okay.
Yes.
Can you move for the parallel combination now?
Yes, sir.
If you take by parallel combination, what I mean, there we will get I as, same method, I will get I as E divided by R plus small r by M. Where what is M? M is the number of rows, and each row I have taken over here to have how many cells? Only one cell. Clear, dear?
Yes.
Each row is having how many cells? There are m rows, each row having one cell. Then you get current equation as E divided by R plus small r by M. So we can replace the cascade by one cell of EMF E and internal resistance small r by M. Correct, class?
So I have a little.
I've done all these with you already, right? This being done already with you. I remember we did for series, we did for parallel. And if you do have any question, Vasudev, please feel free ask. Else
Yes,
I can assume that these are being known to you. Not known, we'll do it. No issues. Yes,
I
dear.
had a little question. What's the difference between having like one cell, I'm talking about ideal cells, like one like for example 1 volt cell and two 1 volt cells in parallel. Both of them are ideal. So what's the difference between having them? Because the potential difference across the ends is the same. So what's
Right.
exactly the difference between both the setups?
Now see, when we come to the situation ideal, then we need to exercise caution. Why I'm saying you need to exercise caution? If I get you a circuit, when I have connected this end to 2 volt and this end to 3 volt, okay?
Yes, sir.
I ask you what is potential difference across R. What are you to say?
So
What current will flow through R? What will you say?
Yes, sir. Actually, I haven't dealt with these circuits before.
So we need to exercise caution when you're talking of ideal cell. We don't get ideal. We are taking a departure from what we get to see in general. In this same circuit, if I incorporate R1 over here, R2 over here, then this becomes a question from here to you'll be able to find. You'll use principle of superposition, correct?
Yes, sir.
One cell at a time, and we'll be able to find, correct? We'll short the other one, we'll be able to find. We are in a position to get an answer to the question which I did coin. But when taken ideal, what to do? Okay, so we are treading a dangerous zone where you ask me that you want to take 2 and take as 2, right? In parallel
Yes.
combination. And then you want to take only 1 in parallel combination, right?
Yes, sir.
What potential difference you have to apply against it?
So
What is
it'll
the
be
potential
same.
difference that I'm applying? I'm at a
Same
loss.
both.
You said what? Can you repeat your question?
So, what's the difference between one cell and 2 cells in parallel? Same potential difference, they're identical.
2 volt, right?
Yes,
And
sir.
then you are having this 2 volt and this also 2 volt, correct?
Yes, sir.
The same potential difference that I'm applying.
Yes, sir. So, what difference does it make if you use the first cell or the second cell?
Won't. It won't. That is what I asked you. That's the reason I asked you this question. That what will you say over here? What is the potential difference? This circuit will not stay. This will burn.
It will.
This circuit will not be operational. This circuit will not be operational if I take ideal cell. Okay, huge flux of current, right? Yeah.
Yes, sir.
So ideal cell when you are taking, you take 2 volt, you take 1 volt, there will be the potential difference remains.
So
The
you're telling me
potential difference is same.
there's no difference at all between the two setups.
Till the time you are not getting me R, there will be no difference.
Oh, okay. So like
If you
no
get me
difference.
R, certainly there will be difference because there will be current flowing through this loop as well.
Yes, sir. So wouldn't like there be a difference in the capacity of the two batteries? I mean, if
The
you're
difference with the capacity of the 2 batteries means if you are getting me a situation wherein you allow leakage of charge, leakage of current, then it's fine. If you are a stout no, there is no leakage, then this is a situation similar to what you get otherwise. Yeah, there will be no difference in the longevity per se, as you have taken ideal cell. So both are to provide you till eternity, 2 volt. 2 volt supply. Okay, far removed from what in general we do get. It's a far cry to achieve this situation. Right?
yes, sir.
Okay. So here you got I. Tell me, are we getting a value which is acceptable for small m? This will be replaced by 8. This will be replaced by 0.5. This by 2. Sorry, this will be 8. This is 5. This is 0.5. This by 2. Tell me what are you getting for small m? Something which is acceptable? Small m.
No, sir. You still get an absurd value.
Yes, we're getting again an absurd value. It cannot be accepted. I think you're getting a negative and a rational number or irrational number. What is it?
So
Irrational.
It's a fractional negative number.
The fraction as of now. Now, what do? We are then but forced to go for mixed combination. Now, mixed combination, what will be the Achilles heel? The Achilles heel will be there being 2 unknowns. So here what we are trying to from this deliberation that we are into, the takeaway will be when we are in a situation where do we have two unknowns but only one equation, how can we make good of that equation by any inference possible so that we can get to the end result? Find, yeah? That is
Yes.
what we are trying to from here as the milking situation. From here, try to milk. Find, yeah? Okay,
Yes.
so let me ask you, what is the equation for mixed combination? Quick succession. Shall we take the mixed combination circuit first? Maybe not taken with Vibha. So I'm taking quickly mixed combination circuit. Mixed combination circuit. How many rows? M rows. How many cell each row? N cells. Please be mindful of the fact that ITJ has got a nefarious design, a knack of changing the constant which you do use. So they may come up with something up their sleeve to surprise you. They can change it to there being how many cells, M cells, and how many rows, N rows. So be mindful of the fact. What I'm writing for on board is there are the equation will be referring to N number of cells each row, and there being M for Madras, M number of cells. Clear?
So, but how do we know that result is going to be achieved by such a symmetric?
Let me write the equation, then you'll get to know.
So because
Right.
how do we know we're not going to have one row with two cells and another row with one cell?
No. If there is one cell, I am taking a case wherein I have got a mixed combination. I don't know how many cells, I don't know how many rows. Okay, dear?
Yes.
But what being known to me certainly is that I cannot get it by parallel. As of yet, what being known to me, I cannot get it by parallel combination, I cannot get it by series combination. Mixed when we study, then we study it for even number of cells each row. Okay, that is what qualifies being called mixed. Even number of cells each row. Clear?
Yes, sir.
So there is no argument there on number of cells each row. Right? That is given to us. It'll be even, egalitarian situation. Right?
Correct.
So we are taking over here how many cells? We are taking over here N cells. N cells each row. And there are how many such row? There are M rows. M rows. ER. To begin with, I am taking same value. See, Vasudev, you can take different values of E, different value of R as well. In fact, this makes a good question. If you are having different cells, what is the equation to shape? I have taken all of same capacity, can be different capacity as well. Then what is the equation to shape when it comes to parallel combination, when it comes to series combination, and when it comes to mixed combination? It makes a good question to solve, right?
Yes, sir.
We are taking same on all the front. Here, this capital R. Now through capital R, what current will flow? As I have taken it uniform, I write I by M over here, I by M over here. All are to contribute it equally. I get I over here, correct?
Yes, sir.
And then I use KVL, correct? Then I use KVL this time.
So
What
just
circuit
want
you have?
to confirm, could you expand KBL?
I will be doing. I'll be doing. This is A. This is B. Okay? And between there are many. The KVL when we write, then we will look for components. I take a simple example first. This is a simple example. Okay? Small r, E, capital R. I want to write KVL. So I'll check for the number of components the circuit comprises of. So how many components are there? There are 3 components. If there are 3 components, you will get 3 points. Point which distinguishes R from E. Let us say that is A. So A distinguishes capital R from E. Then B distinguishes small r from E. C distinguishes small r from capital R. Correct? Then simple mathematics. I don't know much to do about nothing. KVL. KVL is nothing but simple mathematics. VA minus VA is 0. No rocket science that. Correct? No brainer. No non-starter. VA minus VA is 0. What I do now? Expand it. How? VA minus VB plus VB minus VC plus VC minus VA is equal to 0, right?
Yes, sir.
Then I see equal to be VA minus VB. Which one is higher? A is higher, B lower in comparison. So VA minus VB, what will I write for it? E, correct?
Yes, sir.
VA minus VB will depend on cell. It will not depend. This has got no trust with direction of current. Find here.
Yes, sir.
Now I move for R. Here direction of current is material. So when I move from B to C, I am taking current, let us say, flowing in this direction. So when I move from B to C, current is flowing from C to B. This gets me an idea that C is a high potential in comparison to B, correct?
Yes, sir.
So what will be VB minus VC? Negative, minus of I into R. Getting it? Minus of I into R. Getting it? VB minus VC. Second one. Vasudev?
Yes, yes, I got it. Yes, sir.
Okay. Then I go for VC minus VA. VC minus VA again. Current is flowing from A to B, so A is higher. VC minus VA will be negative, correct?
Yes, sir.
So what will I write for that? Minus of I into capital R. I is constant, is equal to 0. This is what is KVL. This is what we word. What do we word? All the potential drops are equal to EMF. That's what we get. And this is based on simple conservation of energy. It is based on conservation of energy. How? Work done by battery, Q into E. In time t, suppose I am observing it for time t. So work done by and time t, Q charge did flow through battery. Okay, dear?
Yes,
So
sir.
work done by battery, how much? Q into E, right?
Yes, sir. Yes, sir.
In that time t, work done by battery QE. This work is exhausted in I square R into T
Yes, sir.
and I square small r into T, correct?
Oh, yes, sir. Yes, sir.
Q is I into T, I can write I into T is equal to I square R into T plus of I square small r into T, IT, go on, you get this equation, correct?
Yes, sir.
So this is based on conservation of energy. And the other one, KCL, is based on conservation of charge. We'll come to that later. For now, I want to write for it. Shall we write for it now? KVL, take any loop. So through this one, how much? Now through this one, just expanding it. What current is flowing through it? I by M. Resistance R, EMF E. I seek value of VAB. This is A, this is B. So we seek value of VAB. VAB will be how much to us? VA minus VB plus VB minus VA, I take C. So VA minus VC, VA minus VC, I have taken C bit to distinguish E from small r. Clear here?
Yes, sir.
So VA minus VC and plus VC minus VB. Clear?
Yes, sir.
Okay. VA minus VC, how much? VA minus VC goes without saying, E, right?
Yes, sir.
And VC minus VB will be negative. Why? V is higher potential. So minus of I by M. I by M is the current into small r, right? Yeah. Do check.
Yes, sir.
Am I clear on this? Clear both of you, yes or no?
Clear, sir.
Okay. Tell me further. Tell me what will it be furthering it?
So you just multiply
This
that
is
by the
for
number
only
of.
cell, this for one cell, correct?
Oh, okay, yes, yes. So you just add that. I mean,
There are
multiply
n
that by
cells,
n
right?
to get for
VAB
an
what?
entire.
Exactly. VAB will be how much? E minus I by M into R, right here?
Yes, sir.
And I'm moving clockwise, let us say, from here to here, what will be potential? Minus of small I into R, correct? Is equal to 0. I started with A, I'm returning to A. Is it okay?
Yes, sir. So this is
A
the
minus
third
VB is this much? And VB minus VA will be how much? Minus of IR, correct?
Yes, sir.
So this is equal to how much to us? 0 to us, correct? We
Yes, sir.
started
So
with A, we are returning to A, right here?
yes, sir.
So this is what we get, and from here we'll get I. What will be I featuring to is NE divided by capital R plus NR by M. Why do I take capital R separately? This gives me an idea that the cascade can be removed by one cell of any value and of internal resistance NR by M. Clear?
Yes, sir.
Where N is the number of cells each row and M is the number of rows. Find here.
Yes, sir.
We have to check. There is no option left, by the way. So there is no point checking. This is the only combination to get you. So we got that we'll be getting it not from series. We'll be getting it not from parallel. So the only resort that we are there with, the only that we can find refuge in, that we can get from which combination? Mixed combination. Correct here?
Yes, sir.
Then I come to the second part of the question. Find the minimum number of cells to achieve the desired. Find the minimum number of cells to achieve the desired. What will be minimum number of cells to achieve what you desire, and what you desire is obvious. The author has asked you to frame. Please do frame.
So basically NM should be minimum.
Yes, we need to know NM. And this is what I was referring to. There are two unknowns, only one equation at your disposal. How will you go about it? Two unknowns and only one equation to your succor. How will you go about it? So how can we go about it here? What to do? Firstly, get me the equation which you are getting. I is equal to NE divided by R plus NR by M is what we got. I is 8, R is how much? R is given to you 5 plus N into, or N by 2M we can mark, 0.5, 2M is equal to how much to us? N into 2, right? Correct me if I'm wrong, right?
It's fine, sir.
Okay, so 40 plus how much? 4 N by M, right here, is equal to twice of N, correct?
Yes, sir.
40M plus 4N is equal to 2Mn. This is the equation with us. This is the equation with us. This is what we are to work on to get the end result. This is the equation with us. Now how can we work on to get the end result? The method is simple. Help me on mathematics if any one of you can. What shall we do? What mathematics should I apply?
So this
Okay,
seems
come
like
to
a
my rescue.
simple Diophantine equation.
Which equation, dear?
Diophantine equation.
Oh, but before of you go to that equation, I wish you to make some changes over here based on what is given to us physically, because we are to factor in the physical part of equation. Physically, we are sure of that M into N will be a constant. Right?
Yes, sir.
So what we can do, we can make good of our understanding. How can we make good of our understanding? Instead of M into N, you write capital N. Instead of M into N, we write capital N. We take it as capital N. So capital N being M into N, what we can replace now? 40, M is replaced by, tell me.
So, N by N.
N by N, okay, plus 4,
N
right?
by N.
I keep N as it is equal to 2 N. Got it here?
Yes.
You
sir.
know what I'm hinting on. I presume you know now what I'm hinting on. Are you aware of what I'm trying to suggest?
So you can
40n
isolate.
plus 4n squared minus 2nm is equal to 0, correct? Is
Sir,
equal to 0, right? Yeah.
Yes, sir.
So what is
Sir?
this to you? Huh.
sir, shouldn't 4n be like, if you're putting everything as n, shouldn't it be like 4 capital N by M?
See,
Because
I'm having reservation with m into n. Why I want to bring m again? I want to remove m from my equation. Either you remove m from your equation or you remove small n from your equation, correct? That's the reason why we are going for capital N. Now what? I think you know what to do. Discriminant should be greater than or equal to 0, correct?
Yes, sir.
Please see to it. What are you getting capital N then from here? Discriminant should be greater than or equal to 0. What will be capital N? Discriminant should be greater than or equal to 0. What should be capital N? What should be capital N? Discriminant greater than or equal to 0.
So you get 4n squared minus 640n is greater than or equal to 0.
And should be greater than or equal to
0.
small n will not feature. Capital N I am referring to.
Yes, sir. I'm
You'll
talking
get
about
only
capital.
capital N.
Yes, sir. So you get n squared minus 160n is greater than or equal to 0.
So n square is greater than or equal to 160, correct?
No, sir. You can factor out an n. You get n times n minus 160 is greater than or equal to 0. So you get n is greater than or equal to 160.
Correct. Okay. So we are getting then n should be greater than or equal to 160, right?
Yes, sir.
Still we are oblivion to how many rows and how many cells each row, correct?
Yes, sir.
That you can get easily when you place the value over here of n, correct?
So
What is the value of capital N placed over here? 160. What
Yes,
will
sir.
place the value of capital N over here? 160, right?
Yes, sir.
When you place the value of capital N 160, you will get small n. Find small n.
So, but like 160 is the answer, right? You wanted the minimum number of
160,
cells.
fine. If I am to supplement it with the number of row and cells each row.
Okay.
Number of rows and cells each row. We are qualifying our answer with number of row and cells each row. What do we get then? We began with the premise that we are getting mixed combination facilitate this, correct? So let us see it through the end. What do we get over here? Just place the value of capital N 160 and try to find the roots.
Yes.
Small n is equal to how much from here?
Is equal to 160. Okay. Yeah, of course, d is equal to 0. So you get 2 times 160 divided by 8, and that should give you 8. You get 40.
40 cells each row, and there are 4 such rows, right?
Yes, sir. 40.
40 cells each row, if it's even, and it is even, as we have gone ahead with mixed combination. 40 cells each row, and there are 4 such rows, correct?
Yes, sir.
Okay, good enough. Next question. There is an infinite network. There is an infinite network with each limb having a resistance R. There's an infinite network with each limb having a resistance R as shown in the figure.
Sir,
As shown in the figure. Find equivalent resistance. Find equivalent resistance between points A and B. They are all R, dear, R, everywhere R. Okay, it's an infinite mess. You have to find VAB against it, not VAB exactly, we have to find RAB. What is resistance across A and B? Look over here. AB, this is A, this is B, adjacent points. Find resistance against A and B. I'm not going to the ladder network, this is a cliche, you're aware of it. I'll take a question if you so require. Improving the ladder network by some factor and then asking you how to solve those questions. First, this one. How will you go about this one? One of the question from Rudolph. You want to find RAB, you have to find RAB. They've asked for RAB, find RAB. It's an infinite mess. What to do, how to go about it? Any idea? Anyone to ideate? What shall I do?
Sir, would you be able to just delete the entirety of the grid except the column with which we're working?
This is any point you can take, any adjacent point.
Yes, sir.
I mean to say current is entering this one and is leaving this one. Find here.
Yes, sir.
You take any adjacent point. You have been asked find RAB. What will you read as resistance across those 2 points? That's it.
Yes, I get it. So you won't be able to delete it.
sir,
Yes, dear. Yes, we are.
so should we find which part would be in series and then parallel combinations? We should find
Then
find
how
that.
will you from here get any inkling, dear? Tell me how will you get any inkling which one is in series, which one is in parallel? It is so just a pause. It's difficult to glean. It's difficult to gauge what in series, what in parallel. What will you say which is in series, which is in parallel? There's nothing of the kind which you can get. And these are the circuits which we do frequent. We do in day-to-day life come across these circuits. I can cite one example in an amusement park. If you see the striking cars, the pole is attached to a network. A current to flow, the pole is attached. I'm not talking about the one which are nowadays the contemporary ones. I'm talking about the yesteryear ones. Pole were to be attached with each striking car. Pole were to be attached with the network above, and that network used to be of the kind this. Iron network. That is what we used to get. We do frequent these circuits. If it is large enough, it amounts to be called infinitely spread. This is infinitely spread. No dimension can be extrapolated or no dimension can be gleaned on. Difficult. You cannot gauge. So what to do? How to go about these circuits? Till the time you have infinite, till the time the circuit is infinitely spread, you are happy in your skin. Very comfortable in your skin. Why do I say so? What do? I break it into 2 circuits. Circuit number 1. Current entering at A, coming out at infinity. Getting it?
So what do you?
Current entering at A and current exiting this network somewhere very remote from A, infinitely distant from A. Infinitely distant from A. Clear, dear?
Yes, sir.
Under that circumstances, if the current enters A, it has got equiprobable situation to move in any direction. Correct, dear? Why? Because out it is to come out. Out it is to come out only at infinite distance from A. Clear, dear? So all the paths are even. Yes or no?
Yes, sir.
If I enters A, I by 4 will go through this. I by 4 through this one, I by 4 through this one, and the same I by 4 through this one. I entered, it did break in 4 equal parts. Why? The situation is even. Where does it come out? At infinity. So if I take A as entrance, if I take infinity as exit, A entrance, infinity exit, this gets me VA minus VB as I by 4 into R. Agreement? Agreement, yes or no?
Yes, sir, but that's still not useful unless we can determine I.
Yeah, I'm coming to that, I'm not completed yet. VA minus VB then will be how much for us? I by 4 into R, right? Situation 2. Entering at infinity, exiting at B. Situation 2, what did I say? Current enters this circuit, this mass, infinitely spread mass, at infinity and parts from it at B. Clear?
Yes, sir.
What do we then write? V infinity minus VB. What is this to get me? What is this to get me? VA minus VB. How much? 1 by 4 into R again. By how? I out, right here. There's no A.
Yes, sir.
I out. So I by 4 from here, 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 collating to I. Correct? So I is up. We get as I by 4 into R. Now what? Neither this is sufficient, nor is this. They are in solo not sufficient. So not them. Right? When added, infinity gone, we get it as VA minus VB. And then over here, adding them as well. What is this to get me? I by 2 into R, rewritten I into R by 2. I the current. So what is the resistance? Equivalent resistance R by 2. Equivalent resistance R by 2. We have used over here principle of superposition, mind you. We have used over here principle of superposition. First cell, VA minus V infinity. Second cell, V infinity minus VB. Added them to get the actual. In actuality, we have VA minus VB. And that gets us I into R by 2. So I being the current fed, R by 2 will be then the effective resistance between A and B. Now towing this line, taking a cue from here. This was the Europe question anyway. Extending it. Tell me what will be VA minus VC.
Sir, I have a
Yeah,
question.
that's why I was there.
So we said VA minus VB is IR by 4. We didn't say VA minus V infinity is IR by 4. Or is
No.
it
We said VA, correct, exactly. VA, when is VA minus VB? I into R by 4 or I by 4 into R. When you have input at A and output at infinity, is that my network? That is not my network.
Yes, sir.
My network I'll get when I add the isolation once. This is
Yes,
the
sir.
network which I took, which is not my network. My network is VA minus VB, correct?
Yes, sir.
This is the network I took to help, to aid me in calculating VA minus VB. And that was possible if I have taken another network where A is the entrance and infinity is the output. For
Yes,
that system, A entrance, infinity output, I got VAB, yes. And that VAB will be I by 4 into R. But that is not what author did position his question at or their question at, correct?
Yes, sir, but the problem is we're then equating that VAB to VA infinity, and I have a problem with that.
I am saying VA, A is the entrance.
Yes, sir.
I didn't write equal to dear.
So, but
A
then that's
is the entrance.
so that's implicit when
Infinity
we
is
added
the
the
out.
two equations, right?
Oh,
Equality
yeah.
is implicit when we added the two equations, right? We said VA minus V infinity plus V infinity minus VB is equal to IR by 4 plus IR by 4. The equality between those two things is implicit when we added them.
Correct.
So how did we
Yes.
get that?
Because when we are calculating, we took two cells. That is what I told you. Principle of superposition. One at a time. What is one to provide? I got it. What is the other to provide? I got it. Now what I am to do, they are in isolation. What does principle of superposition say? Effect of a cause is independent of number of causes present. If one force present on this produces an acceleration A1, then that force will produce the same acceleration A1 even if there are, or even if this body is subjected to thousands of forces, correct?
Yes, sir.
Or if one wave is to displace, you have studied principle of superposition at three places. First it comes in force, then it comes in waves, and lastly it comes in current. If one wave produces a disturbance of y, then that wave, even if it's accompanied by 1,000 wave, will produce the same effect I. Net effect, of course, will be vector addition, isn't it? Yeah.
Yes, sir.
Isn't it? Getting it or not? Let's say
Yes,
it is a particle F1 acting and F1 is producing A1 acceleration. Now on this particle, F1 is acting, is also acting F2, is also acting F3. If is asked what will F1 in solo produce, it will produce the same acceleration A1, correct?
Yes, sir.
Yes. What will be then the total acceleration? That will be vector sum of individual accelerations, correct?
Yes, sir.
This is what is called principle of superposition.
So how does that link to this?
I have a cell. I took that, right?
Yes, sir.
I have a
But
cell, small r, E, capital R, E1, R1, okay? E2, R2, correct?
yes, sir.
I want to calculate what will be current flowing through this one, fine?
Yes, sir.
What I do? I take one cell at a time. What will I do? I'll remove this. I will not remove R2, mind you.
Yes, sir.
I'll calculate what is current now. I get I1.
Yes, sir.
Then I will remove this one, bring this back. I'll calculate what current through this. I get I2.
Yes, sir.
Then individually, right? Individually we are finding the values.
Yes,
And
sir.
then adding them. When I add them, I get the actual circuit, correct?
Yes, sir.
So what will be the current there? I1 plus I2. If they were in same direction, correct?
This is just not as intuitive as it would have been for forces.
Yes, it is superposition. That is what we call superposition. As if the other one is not into existence. And then we add, and it doesn't add up, maybe logically, but that is what the process is. Okay? Why doesn't it add up? Because it's difficult for us to understand how can the situation be mutually exclusive. And that is what it is. As it is mutually exclusive. Okay? So what do we get from here? Exactly the same. V minus VB from one, from the other, adding them, I into R by 2. Extending it to find what will be VA minus VC. Can you get me? Not difficult. What will I do? Next, what can I do? Tell me. How will I find? From here, again the same scenario, entering at A, coming out at B, correct?
Yes, sir.
So I by 4, what will happen to I by 4 now? I by 8 this side, I by 8, I by 4 is coming, right? So how much
Yes.
will go? Tell me. I by 4 comes this way. It will split into equal halves, right?
I by 12 in each.
I by 12. I by 12 over here, I by 12 over here, I by 12 over here. Getting it?
Yes, sir.
So,
And then I'll calculate what is this in case 1. case 2 the same, coming out from here, right? So this will be in case 2, I by 12, I by 12, I by 12, and this will be I by 4, correct?
Yes, sir.
We'll calculate similarly. We'll be able to get what is R equivalent. Find here. Shall we move on? Shall we move on to the cube one, the mechanical question? Though must the value be known to you? 5R by 6.
Yes, I still have this lingering doubt. You, yes, you never wrote VA minus V infinity is equal to IR by 4. You never wrote that, and that is false.
I will write it as I into R equivalent. How can I write I into R? VA minus V infinity if I am taking, then I will write it as I into R equivalent. I cannot write it as I into R by 2 or I by 2 into R. No.
Yes, sir.
VA A entering, infinity out. I don't know what is inside. Inside yes. To me is a black box, and that blocks have what is the R equivalent of that black box? That should be known to me to equate them. Correct?
Yes, sir.
So I'm not writing. We cannot write that.
So, but like to add them, we need to know they are equal, right? Otherwise, how else can we add the two sides of the equation?
Adding them. I don't want R equivalent because the question was not on R equivalent. The question was R equivalent as seen across AB. You're confusing. I am not finding R equivalent for that mess. I'm finding R equivalent across 2 points AB. Getting it?
Yes, sir.
If I am to find R equivalent, certainly I should be aware of it. Only then I can proceed. For example, there are many a case which you can take, and that being I have got a sphere, I have got a cube. I want to find R equivalent. How will I find R equivalent there? We can set an example. That will be a different ballgame altogether.
Yes, sir.
Are you getting it? There's a different scenario. There I will use R equivalent. I'll use VA minus VB is equal to I into R equivalent. Here I'm not supposed to, because R equivalent is not asked across A and infinity. That is not asked. R equivalent is asked across A and B. Getting it?
Yes, sir.
So let us take an example to substantiate what I did say. Find R equivalent across. Find R equivalent across the point shown. The point shown in the cube. The point shown in the cube. This is A to me right here.
Yes.
This is B to me, diagonally opposite. Clear here?
Yes, sir.
Diagonally opposite, body diagonal, not face diagonal. Clear?
Yes, sir.
Okay, this is A, this is B. What I do? I feed current I.
This is actually an NCRT problem.
Yeah, this is mechanical. That's the reason. I'll take the third version of it. Third one is much to gain than the other two. There are 3 versions. The other 2 are mechanical. So you know how the current will split and accordingly R equivalent can be gotten.
Yes, sir.
The only point that I wanted to bring forth is what we do over here. We write VAB is equal to I, which I have fed, into R equivalent, correct? Because yes, I have to find across A and B. Clear?
Yes, sir.
A is the entrance and B is the exit.
Yes, sir.
And then I equate it with, you are well aware of, this will be I by 3, I by 3, I by 3, symmetric, correct?
Yes, sir.
This will be I by 6, this will be I by 6, and this will be I by 3 again, I by 3, and I by 3. What do? I take a path, correct? Take any path, this, right here?
Yes, I think you miswrote in some of the values. That should be I by 6.
Yes.
So I think you have miswritten some of the current values for the...
I by 6.
Yes,
I by
sir.
3, I by 3, I by 3, fine.
So one of the I by 3, it should be an I by 6 because on the
I by
same
3, I
higher.
by 3, I by 3.
So no, that should be an I by 6, the one you just
Achha,
pointed
this one I
before.
by 3, I by, we got from here.
That's an I
by
by
3.
6.
Which
Right?
one? Which one?
So if you move towards the right.
From here, it will bifurcate into 2, I by 6, I by 6. This will be I by 6.
So that'll be I by 3.
Okay.
That'll be I by 3, sir.
This will be I by 3, this will be I by 6.
Yes.
Okay. Right?
Yes, sir.
I by 6, this will be I by 6.
Yes, sir.
Because I by 6 goes away. I by 6 from here, I by 6 from here, I by 3. I by 6 from here, this will be I by 6 as well. I by 6 from here.
So that's I by 3.
This is I by 3. Right?
Yes, sir.
I by 6 from here, I by 6 from here. And this is
Yes.
I by 6, right?
Yes, sir.
Good now?
Yes, sir.
Now we try to find what will be. So VAB is equal to from here to here. I by how much? I by 6, I by. How much this? I by 3 into R plus I by 6 into R plus I by 3 into R. Right? That's what we do and equate them.
Yes, sir.
That's what we do, correct? Yeah.
Yes, sir.
We get from here 5R by 6, correct?
Yes, sir.
Now to the one which I was referring, which we will solve, and that being edge, across the edge. It's important for us, across the edge. How do we go about across the edge? This one, this one, this one, this one. This is the entrance and this is the exit. I entering, I coming out. Yeah?
Yes, sir.
Okay, what can we say about this one? This will be I1, let us say. This will also be I1 owing to symmetry.
Yes, sir.
Phase, correct?
Yes, sir.
But this will be different. It has got a different part to follow. So let me mark it I2. Equation number 1, I is equal to I2 plus 2I1. Getting it?
Yes, sir.
Equation number 2, VAB is equal to I2 into R. Now check what did I write. I didn't
Yes, sir.
write R equivalent. I2, correct? I2 flows
Yes.
through because I've taken I2, right?
Yes, sir. So if we were to use I, then we would write I times R equivalent.
VAB, then I will use R into R equivalent, correct? I into R equivalent because I fed.
Yes, I get it now.
Got it? So VAB is what to us? I2 into R and VAB otherwise in terms of I and R equivalent, I into R equivalent. Clear here?
Yes.
Okay. What next? This breaks. Let's say I get over here I3. What will it be? 2 will be I1 minus I3 firstly. I1 minus I3 to check there. Here I1 minus I3 because I have taken I3 down. Here also I3 down. So what will it be? I1 minus I3. I1 minus I3 from here, I1 minus I3 from here. So how much this will be? Is twice of I1 minus I3. Do check, correct?
Yes, sir.
And accordingly, they will split over here. I1 minus I3. I1 minus I3. I3, this is I1. And this also is I1. Fine?
Yes, sir.
You can loop around and get a relation between I1 I3. Okay? And take this loop and come back to this point. Get a relation between why I want I1 I3 relation is pretty simple. VAB is equal to what to us? I have written I2 into R, correct?
Yes, sir.
So I2 into R, I want all in terms of I1. I want them to relate, correct?
Yes, sir.
So what we can write it to be is I minus 2I1 whole into R, correct? Now your job is to get me I1 in terms of I. Can you? I1 in terms of I. I want I1 in terms of I. You can get very easily by moving across any loop, yeah?
Yes, sir.
Okay, very easy. Let's move in this loop. This one, this one, this one, this one. Right. See whether we get an equation or not. So I1 minus I3 R plus twice of I1 minus I3 R plus I1 minus I3 R this way and then up minus I3R. You check, correct?
Yes, sir.
Is equal to what to us? 0 to us. We have traversed a loop, potential difference will be 0. This is to relate. What I wanted, by the way, I didn't want I1, right? I wanted I2, right? Wait a minute. I wanted
So-
I2, right?
Yes, yes. Sir, if you go around the loop, does the direction of current have anything to do with the signs you take for the potential drops?
Direction of current, here.
Yes, sir. Does the direction of current in any way influence the signs you take for the potential drops when you go across?
Direction of current will decide on potential drop, right?
Yes, sir.
It will decide on potential drop because current will move from higher potential to lower potential. So you'll have to keep to it.
Yes, sir.
You can take it in any direction. Symmetry should be over here justified. If it is coming out this way, it will collate, or it will, if it is parting this way, then it is later to relinquish the same way.
Yes, sir.
Okay, dear?
Yes, sir.
So this was not to work. Tell me, what should I go by? Which path should I take so that I am
So
able to relate I1, I2?
So
Anyway,
it's
this is
actually,
one. The other way, take this one. Fine. This face, right?
yes, sir, but
This
that
face,
still
this face
has
will
an
relate
I.
I1, I2, right?
It still has an I3 though.
This face, this face.
Yes, sir. It
You
still
have
has
to
an
write two
I3.
equations. So what will it be? It will have I3, but we'll remove I3. I want I. I want, this equation is I is equal to how much? 2I1 plus I3 we got, correct?
Yes, sir.
This equation is getting me V2. This is getting me I. I we can write over here as I2 plus 2I1. See, whichever way you want. You can write it as VAB is equal to what to us? Now instead of I, what we can write? I2 plus 2I1 into R equivalent. Fine? Fine?
Yes, sir.
Now then we will have to replace I2 and I1 in terms of I. I2 and I1 in terms of I.
Yes, sir.
Yeah? So far as I2 is concerned, we have a reason for it. What we can do, VAB, we can write simply I2 as VAB by what? R, correct?
Yes, sir.
Now what about I1? What will
So-
replace I1 by?
So you could do the same thing. You could say I1 is equal to I minus I2 by 2, and then again replace I2 by VAB by R.
Correct? Do it.
So, but then that didn't require any of the analysis we've been through in the last couple of minutes. So
Come again, dear?
So doing that doesn't require any of the analysis we've been through in the last couple of minutes. So what gives?
No. How is not that required? What I1, I2? How will you get I1? How do you get this will be I1 and this will be I1 as well?
Yes, that was a consequence of the inherent symmetry of the problem.
Yeah, of course. I'm bringing symmetry over here. We are
Yes.
going by symmetry. If you want to go by potential, we can say which part will be having. Think about it. Which ends are to be same on potential? One can ask this question. Means you can squeeze this circuit to a planar figure. If you know that which points when are met, it will not spark. We can take a symmetric and we can fold it this way. Why?
Yes,
Because
sir.
when the points will meet, they will not spark.
Yes, sir.
So here also, if you know equipotential, in fact, that makes a very good question. Find how can you squeeze it? How can you squeeze the circuit? It will be all the more easy than to find R equivalent. You'll get parallel combination, you'll get series combination. So either you use that or use symmetry. This is only for uses of symmetry.
Yes, sir.
So from symmetry, we'll be able to find relation. Once you got relation, you'll be able to find what the R equivalent is equal to. We
Yes,
get
sir.
it in this case 7R by 12. R equivalent equal to 7R by 12. Remember these values because they can get you in matrix form as well. 5R by 6, 3R by 4, 3R by 4 for face diagonal. 3R by 4 for face diagonal. And for edge, 7R by 12.
So what was
For
5R by
edge,
6 for?
5R by 6 for body diagonal.
Ah,
Body diagonal. 3R by 4 for face diagonal. 7R by 12 for edge. 7R by 12 for edge.
yes.
As we are trying to bring symmetry angle, let me ask you a question on symmetry quickly. Let me take an example where you will cite symmetry. Let's say there's a pyramid. Current enter here, leaves here. Find R equivalent. All are R. Between 2 points, any 2 point, resistance is R. Find R equivalent. It's a pyramid.
Yes, sir.
You know what to do by symmetry. They will reconcile in the same manner as they part, remember. Because current will not be able to distinguish if you change path of current. It will not be able to distinguish. So it is to reconcile following the same pattern as it did part.
Yes, sir. So I have a suspicion that no current will be flowing through the edges which connect the apex of the pyramid to one of the
A, B, C, D. You can mark them now. A, B, C, D, E. Tell me.
Yes, sir. I have a suspicion no current will flow through AE and DE. Is that right?
A, E, and E, D.
Yes, sir.
Absolutely right you are. No doubt about it.
Yes, sir.
This will have a current, let us say I. This will have a current I going to symmetry. This may have a different current because path is different, so I am marking I prime. But I know that it will reconcile in a similar manner. So this should have I, this should have I, right?
Yes.
And this should have I prime, which makes AE and DE deformed. There will be no current flowing through them. Now you know what to do, right?
Yes, sir.
Having 2R in parallel with 2R in parallel with 2R, correct?
Yes, sir.
2R, 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 they are parallel with each other, you will be able to find R equivalent. Okay, let me change the point now. Entrance C, exit D. Entrance C, exit D. Entrance C, exit D. What about this one? Draw fresh for you. Okay. Then on.
So could you label the points? It would be easier to graph.
That's all. A, B, C, D, E.
Yes. So all the three initial edges, AD, ED, and CD will have different currents going through them.
So they will have, let's say I'm marking this as I current. Okay?
Yes, sir.
Okay, so it goes I, or I1, it breaks into I2, I3, fine?
Yes, sir.
Okay. This one, I4, fine here?
Yes, sir. So then EC also has to be I4.
Which one?
EC also
DC
has to
need
be
not be I1.
I4.
No, DC need not be I4. Why?
So EC.
Correct. EC.
Yes, sir.
EC.
Yes,
That
sir.
will come to. For now, this is I5. Okay. Now, as you suggested, rightly so, EC should also be I4. Why? Because reconcile in a similar manner. So this will be I4. This
That
will be
means EB has to
I5.
be
And this will be
I3.
I1. It will reconcile in a similar manner, right?
Yes, sir.
What is then to be said? You can open the canopy. There's no merger of current over here. I4 goes up and it's getting reflected, correct?
Yes, the I3 also goes down similarly from
Yes.
EP. So
I
there's
think also
no.
goes, so you can open it. There's no mixing of current at the top. Thereby, you get a circuit of this kind. Right? Isn't
Yes,
it?
sir. Yes, sir.
You can open, you can get the value of R equal. So these are few that we do gauge vis-a-vis symmetry. Symmetry do work over here. If the circuit is symmetrical about a line, then you can follow the circuit about that line. Given a circuit of the kind, let's say this is given to you. This way, this is repeated. Okay? So the circuit is symmetric about this line. Okay?
Yes, sir.
Symmetric about this line. What you can do? You can fold it. Potential difference will remain same. This point will have same potential difference at this point will have same potential difference at this point. Yeah, you must be aware of that you are finding about A and B. This is A, this is B.
Oh, yes.
So you can fold it. And accordingly, if it is easier, by folding it, you will be able to find it out. Tell me about this one, quickly. Find equivalent resistance. They all are, they all are. Find equivalent resistance. What can we do by Arrhenius symmetry? What can we do? What can we say? Anything you're making out over here? Vasudev?
Thinking.
Okay. Take your time. What about this one? If I current flows in this I1 and if I2 in this, fine?
Yes.
One thing we are sure of that this will be I1, correct?
Yes, sir.
And this will be I2. Say yes or no?
Yes, sir.
In that case, we can remove this connectivity. Because I1 came and I1 is to go this way. So you can lift it up, right?
Yes, sir.
As if it is not connected. So you get a
this.
circuit of this nature. 2R, R, 2R. We know now what to do.
Yes,
Correct?
sir. Yes, sir.
Correct? Is it okay, Viva? What I did? I1, so there's no mixing over here. I can raise it, I can dissociate. This point is being disassociated. Disassociated, you are lifting it up. It's not connected. It's appearing as if it is not connected. That is what is implied. And then once we are done with it, we get 2R in parallel with R, in parallel with 2R, and then 2R, whatever here.
Also in parallel with 2R.
This will be R, and this will be 2R. Getting?
Yes, sir.
This you can find easy. Now to the question, which I was referring to, infinite circuit. This question only. It is in Krutov. What does Krutov say? He says that you are having this circuit, okay? Inside of it are the triangles, multiple triangles, okay, dear?
Yes, sir.
Diminishing in area. So if it is 2L, this is L, this is L by 2, half, okay?
Yes, sir.
Find RAB.
So the
Find
triangles keep on going.
Yes, dear, yeah. Infinite circuit.
Okay.
Find RAB. Find RAB. How will it go about?
So it actually forms what looks like an infinite cascade of series and parallel circuits. It at least looks like it can be reduced to that based on what we've done in the previous problem. If we keep applying the same concept of being able to detach the apex of the triangle from.
Okay, I will detach. I will remove.
Yes,
No, but if you keep on removing, then what circuit you have to get into?
So you'll
Current
get
will flow
some.
in it, right?
So you'll get some
You can
combination of
remove
series
this.
and parallel circuits, right?
Yeah, okay, you can remove this.
Yes, sir.
So
So
be mindful of the one which you can remove. Yes, please, go ahead.
eventually, I think you'd end up with a sum which can be computed because in the end, it's just series and parallel, right?
I'll do the line that you are suggesting with a tweak. The tweak being, forget about the outer one, think about the inner one. Inner ones. If this is VA, this is RAB, then what will be across this one? Will it not be RAB by 2?
So how by 2?
Yes. This is RAB with length twice.
Oh,
Now having inside a circuit, half of the length.
Yes, yes.
So what we can remove entire of this by is 1, which is what? RAB by 2. RAB by 2. Now you are equipped to solve it. R is easy to solve, correct? You can solve it. Check it out here. Is it? Yes or no? Still confused? No issues? I take you one. This will make it amply clear to you what I did over here. So this is an infinite circuit, okay? This is A, this is B, okay dear?
Yes, sir.
This is R, this is R, this is 2R, this is 2R, okay? This is 4R, this is 4R, fine?
Yes, sir.
What do? I take 2 common. When I take 2 common, I get the same series, correct?
Yes, sir.
How do I solve? R, and instead of this, twice RAB. Don't we do this?
Yes, sir.
Twice RAB, right?
Yes,
Then we take this as AB. This is how we do. There the ratio was of compounding 2. And the ratio is of devolving by half.
So could you say how it was cut by half again, Mr.
Half. Because resistance was dependent on length, let us say. And length was half. Or you say resistance half.
Oh, like
This is R. Now this was R. I wrote R for it. And it is based on length, let us say. As the length is reducing to half every time, what happened to resistance? It is to follow the suit.
yes, sir.
Okay? So you can write it as A rho root 7 minus 1 by 3 is what you get, the answer. A rho root 7 minus, where rho is the resistivity, of course, A is the side length. Root 7 minus 1 by 3. This is one of the question from root 2. Okay, this for the day. We'll see what next to be taken. Fine. Thank you,
Yes.
Vasudev. Thank you, Vibha. Okay, looking forward for the classes and on other subjects as well. Surely we are going to look forward for the part wherein we are supposed to invest now, and that is, as you know, the profile. It's important for me. It's important for all of us. So associate yourself with whatever possible, whatever coming your way, rather hunt for them.
Yes, sir.
Okay, and continue with the work which you are already in. Thank you, dear. Thank you, Vasudev.
Thank you, sir.
Thank you, Vibha.